Hi, in this section, let's talk about the thread confinement of local primitive and the reference variables. Here is an example. The author is trying to demonstrate, and even though the sorted set animals, this object is not a thread safe because tree set is not a thread safe. However, since the animals is a local variable, it is confined in the calling stack of the enclosing method. So even though multithread call this loaded arc method simultaneously, this animal's object is not shared among them. They are confined in the stack of the loaded arc. So they are also confined in the particular calling thread. It's not shared among threads. Okay, I have write a main method for this program so that we can run it. Let's just copy paste to save some typing. Let's fix eclipse package. Okay, run it. We have 26 pairs and unicorn is in on the arc. Okay, the main method is like this. First, I create an animal instance. Through the animal instance, I access a new keyword of its enclosing class arc. So this syntax is needed because arc is a inner class of animals. In order to create a new arc, I need to access a new keyword through an instance of the enclosing class. The same syntax is used here, and that's how we create a candidate as a tree set. So once a candidate collection is created, I iterate through the species and gender elums and add the animal with that species and gender. There are 26 species and 2 genders, so totally we have 52 animals added to the as a candidates. Once we have a candidate, we call the animals loaded arc and print out how many pairs we have loaded. Finally, we check if unicorn is on the arc. Let's take a look at the hasAminal. This one I added to check if a specific species is on the arc. So I iterate through the private variable, which is a hash set. I get an AnimalPair and I get one of those member of the pair and check the species. If it match, I return true. Otherwise, iterate through the whole collection and return false. Let's say the fraud is coming. We want to hurry up. So instead of have the main thread to load the arc, we create a new helper to speed up the arc loading. So let's start the helper. We have a helper ready to take task. So let's give it a new runnable so it can do some good work. Let's say have the eclipse to autocomplete. Spoiling plates code. Now we have a helper eager to help out. Let's give him some work to run. As the code stands, the helper is not really helpful because it's trying to load the same candidates. The main thread is start loading, so they do repeating work. It's not speeding up. You see, 26. They both loaded 26, so repeated work. We can fix this by have them load different candidates. So if your species to string char at The first letter of your species name, if they start with a letter later than say H, we use the main thread to load this species. Otherwise, we use helper thread. Okay, let's change this code. We don't need to change the candidates because it's a local variable of the helper, even though they have the same name. But if you want to avoid confusing, let's give it a different name. Of course, here it's loaded the other half of the species. We intentionally have an equal because we allow overlaps. We are dealing with a set. Now we have a helper load some of the species, the main threads load the rest. So let's see. The main thread loaded the unicorn, loaded 19, and the helper loaded 8. Let's give some check. If the main thread loaded every species, I doubt it. How about the helper? Okay, the main thread missed this exotic animal, and the helper catch it up. Good work. Looks like it's a happy ending. We are done. No, not yet, because at this point the program appears to work. However, it's not good for multi-threading. We have to check if all the shared variables are guarded for thread safety. The arc is one of the state variable. The arc is shared among the threads. Let's check the code path of the arc. Arc is called, we call the arc load. In the loaded arc, who calls loaded arc? So the main thread calls it, the helper thread also calls it. So this code path needs to be guarded. Okay, let's first check this. Load the arc, and let's see the arc, this load. Let's check this code path. Here, the loaded animals private variable is shared among threads. So, and let's check the hash set is not thread safe. This is a problem we need to fix. We can fix it by wrap it inside the threadSafe wrapper. So as long as we always access this hash set through its threadSafe wrapper, we should be all good. So the load is guarded. Let's check its other code path. Is there any other code path not guarded? The arc is also called in the main thread. We have the hasAminal. This code path is shared among multi-threads, so we need to check its thread safety. Here we have the species, and here have the shared variable. Okay, this variable is shared among the threads. However, we already fixed it. So looks like we are all done with this arc. All the public methods are now thread safe. We are good. Let's run the program, and we get the same result, but in a thread safe fashion. So this time it's happy